Hi there, this is Ellen Creeves from EMC2 Mathematics. I'm here today to talk about solving systems of three equations. And as you can see here, we have three variables, three equations. We have a variable represented in each equation. So we're going to talk about the basic method for solving these types of problems. So when we have three variables, it's really difficult to use substitution. It makes the problem longer, more complicated, and there's a lot more room for error. So we're going to focus on the method that we learned when we did systems of two equations with two variables, and that is elimination. We want to try and get rid of a certain variable to help us out. The goal is we're going to take these three equations, we're going to use two at a time, and we're going to eliminate one of those three variables. And you'll see what happens after we do that. So I'm going to label these. This is equation 1 up here, number 2, and number 3. So that's how I'm going to refer to them. And with elimination, if you remember from systems of two equations, we want to see, is there something easy that I can add or subtract? It'll go away right away, that I don't need to multiply by anything. And do you see it in any of these? Looking at the x's, the y's, or the z's? Remember, we're only putting together two of our equations. So either 1 and 2, 1 and 3. Do you see it with 1 and 3? I'm going to use 1 and 3 for my very first one, because in 1 and 3, I have this negative 2y and positive 2y. Those are additive inverses, so when I put them together, they're going to go away for me. So here's 1 and 3. And I'm going to write those down. We've got x plus 2y minus 2z equals 3, and x minus 2y plus z equals negative 10. So a lot of times my students say, these are so hard, Mrs. Creeves. I get them wrong every single time. Well, a couple of little things for you. It's not so much the process. It's all about the algebra, showing your work neatly and consistently. You're going to see I'm going to work down. I'm going to try and write things as neatly and as legibly as possible. I'm going to make sure my negative sign doesn't get misunderstood with the equal sign. And I write my z's with a little line in them because my 2's look like this. Some people write their 2's with kind of that squiggly bottom. I don't do that, so I put a line through my z's not to confuse them. All right, so let's use our process, and I'm assuming you know elimination, which is taking these two and adding down. So when I put those together, I'm going to get 2x. My y's are going to cancel, yay, to get 0. And negative 2z plus z is going to give me a negative z equals 3 minus 10. Don't forget to add these. That's very important. So look at what I got. I have an equation now with two variables. That's phenomenal. That's what I'm looking for. I've eliminated one. Well, can I solve just using one equation with two variables? No, two equations for two variables. So I go back up here and I say, okay, is there another place where it's pretty easy to eliminate y? I can't use 1 and 3 again, otherwise I'll get the very same equation. I need to pick something else. I could pick 1 and 2, 2 and 3. Which one would you like to use? We might choose the same, we might choose differently. I am going to look at what do I have to do to 1 and 2 to eliminate those? Well, 1 has a positive 2y, number 2 just has a positive y. So I'm going to multiply equation 2 by a negative 2, because that will help me eliminate that y value. And when I multiply it by negative 2, I need to be sure that I multiply by this number, this term, and this term here. This one is often left out. I don't have a lot of room on this side of my board right now, so I can't write the negative 2 over there. But a lot of times students write it over there, they get done, they rewrite all of this, and they forget to multiply that one by a negative 2. That's pretty important. So I'm going to continue my work for this one right below, and I'm going to highlight. I had a student yesterday with a highlighter that I love, so that's my highlighted two variable equation here. So I'm going to use 1 and 2 next. So I'm going to rewrite equation 1, which is that x plus 2y minus 2z equals 3. And I'm going to go ahead and multiply this negative 2 by each of these terms. So help me out. Negative 2 times 2x gives me negative 4x. Negative 2 times a positive y gives me negative 2y. Negative 2 times positive 3z gives me negative 6z. And negative 2 times that negative 1, I didn't forget, gives me a negative 2. So again, elimination of those, adding down, I get negative 3x. I cross these out because positive 2y, negative 2y give me a 0. Negative 2z and negative 6z give me negative 8z. And then I get a positive 1 when I take 3 and negative 2. So I'm going to put another box around those because those are now my two wonderful equations that are down to two variables, both with x's, both with z's. That's the goal. We eliminated y. Perfect. So I'm going to take those two back up top here. Just going to erase that times negative 2 so we don't get confused with it. So I'm going to take 2. A lot of times, because I'm working sideways, I'll draw a line. It helps me stay organized. I'm just rewriting my two equations. So I have 2x minus z equals negative 7. Trying not to get in the way here. And then negative 3x minus 8z equals 1. All right, so this goes back to your regular system with two variables and two equations here. I want to use elimination. So if I'm going to use elimination, which one's easier to eliminate? Which one do I maybe only have to multiply one equation by? That would be the top one. What would I multiply by if I want to eliminate z? On this top equation, what do I multiply by? Did you think negative 8? If you thought negative 8, you're correct. I'm going to take this whole thing and I'm going to multiply by that negative 8. Okay? Because that's going to change this when we multiply. So I'm going to rewrite these both. I'm going to distribute negative 16x plus 8z equals positive 56. Negative 8, negative 7, positive 56. Don't be afraid to use your calculator. I'm not judging you. If you have a scientific calculator and you need help remembering what 8 times 7 is, use your calculator. I want you to get these right. I want you to feel confident. And sometimes if your arithmetic is catching you up there, let the calculator help you out a little bit. All right, so then we write down the second one, negative 3x minus 8z equals our 1. Again, we're going to eliminate, adding down. So negative 16x, negative 3x, negative 19x, positive 8, negative 8, it's going to get me 0 equals 57. Awesome. Look at what I have, a very simple one-step equation. I divide by negative 19 here, and I get, anybody know the answer to that? It is going to be a negative 3. I kind of did that in my head. You can use your calculator as well. I know that 20 times 3 is going to give me 60, and 19 is one less than that, so I took away 3, if that makes sense. So I have one piece of our coordinate system, or coordinate point that we're looking for here. X equals negative 3, because my final answer is going to show up in the form of x, y, and z for this particular equation. It won't always. This means that our three planes cross at a point. 3 planes can cross at a lot of different places, but in this case, we have a coordinate here. We're going to keep going with this type of solution because some of the other ones get a little complicated and we want to focus on getting you these. So x minus 3, or x equals negative 3 is one of our answers here. So what do we do with this information? Well, we start to put it back into this coordinate, but I don't have the other two terms. How do I find y and z? Well, sometimes people say, okay, we'll plug it back up into here. Okay, so if I put negative 3 into this x, I can do that, but then I'm still missing y and z. So where might be another equation that I could plug negative 3 into and get either y or z right away? I could plug it in here, or I could plug it in down here. Either one. I'm going to use the top one. I'm going to say 2 times negative 3 minus z equals negative 7. Do you see that? All I did was plug in negative 3 for x there. So this gives me negative 6 minus z equals negative 7. I'm going to add 6 to both sides. Two-step equation here. Negative z equals negative 1. Divide by negative 1, and we get z equals positive 1. Awesome. So that goes up over here for 1. So now we just need to find y. Well, can I plug something into these two and get y? No, they don't have y. I have to go back up to something like this. Why don't we use this one that I'm pointing to right here? X. So if I'm going to rewrite this, x minus 2y plus z equals negative 10. I'll draw my line so you don't get confused as to where I'm going here. And I will also highlight the fact that we got z equals 1. So I'm plugging in my x value in for x here. So that's going to be negative 3 minus 2 times y, because that's what I'm looking for, plus z, which is 1, equals negative 10. Okay, I'll get confused with these guys over here. So I get negative 3 minus 2y plus 1 equals negative 10. So I get negative 2 minus 2y equals negative 10. All right, so then I add 2 to both sides. Notice here I just combined like terms. Students complain sometimes about teachers moving too quickly in certain areas. When we're moving too quickly in certain areas, that means that we're just doing some stuff in our head that we may be so familiar with that we forget to show you the steps. So if you're sitting in class, raise your hand. Say, I'm drawing a blank here. How did you get from this step to this step? And teachers can go, oh, well, I'm combining like terms, or and show you. So don't be afraid to ask those questions. I encourage my students all the time, ask something when you don't know it. It's always better to ask. Stop the teacher, ask them to explain again. And if the class time is not the right time, if you feel like the teacher isn't able to spend enough time, go in afterwards, go into a resource room, go in before school, email your teacher, communicate with them. They're there to help you. Okay, so y equals 4 is our answer here. Yay! So now we have our 3 coordinates, negative 3, 4, 1 in our system there. And is this where I'm done? You know, we could get all these answers. They look really nice. I really like a negative 3, a 4, and a 1. It's not crazy decimals. But I don't need to stop here. I can actually go back and check my solution. So I can choose one of these equations up here and see if it works for those equations. So let's try one. I didn't use it. Let's try number 2. So equation number 2. So just so we can, this is where we're checking, okay? Checking our solution. So if we write that down, we've got 2x, this is the original equation, plus y plus 3z equals 1. I'm going to plug back in each of my variables. So 2 times negative 3 plus a 4 plus 3 times 1 equals 1. Now I'm not solving this, I'm actually asking the question, is it equal to 1? So I'm only going to do this side to determine if it's equal to this side over here. So 2 times negative 3 is negative 6, plus 4 plus 3, is that equal to 1? Well, negative 6 plus 4 is negative 2 plus 3, is that equal to 1? I'm showing you all steps here, so 1 is equal to 1, yes. So this indeed is a solution for this system of equations. So I hope that's helped you a little bit. If you have any further questions, you can email me, emc2mathematics@gmail.com. Have a great day.